Good evening, everyone. Welcome to this tutorial class on discrete mathematics. Today is week 12, and we'll be discussing week 12 assignment questions from previous iteration of the course. And this is the final lecture. So I'll start by sharing my screen. Okay, so these questions are related to advanced topics in counting. So I'll get started with the first question that we have. Just 1 minute. Okay. So the first question is, so which of the following is equivalent to 2 times of this series given? So to solve this, we have been given four options of various different variations of e to the power x. To solve it, so just recall what e to the power x is. So e to the power x is 1 plus x plus x square over 2 factorial, which is 1 factorial, plus 3 over 3 factorial, which is 4, and so on. And e to the power minus x will be 1 minus x over 1 factorial plus x square over 2 factorial minus x cubed over 3 factorial plus x 4 over 4 factorial. So in e to the power minus x, the sign keeps alternating, whereas in e to the power x, it remains plus. So now if now we have to get this series. So we have x cube and x all the odd powers. So if you look at these two expressions, e to the power x and e to the power minus x, so we'll have to eliminate these even this these terms. So we'll have to eliminate these these. So the simple way to eliminate would be just e to the power x minus e to the power minus x, because in the first expression and in the second expression both the terms have the same signs, so we use a minus. So what we get is twice of x over 1 factorial plus x cube over 3 factorial. So the minus before this e to the power minus x makes this minus before x by 1 factorial as a plus. Similarly, the minus before x cubed by 3 factorial becomes a plus. So we get this series. So this is the answer for the first question. So this question was just to get you familiarized with this important series e to the power x. So it will it is used mostly in generating functions while writing generating functions. So in such cases, you'll have to keep it in mind. So the right answer for this question is C, e to the power x minus e to the power minus x. Coming to question number two, which one of the options does not satisfy all properties of group? So first let us write down what are the properties of group. Properties of a group. So you have four properties. So first one, so a group is defined by its element G and an operation. So this circle that I have drawn is represents any operation. It could be plus, it could be minus, it could be division, it could be multiplication or anything. So a group is defined by a collection of by a set. This is the set, and this is the operation on the set. So the first property is that if um, is A comma B belong to G, so we pick any two elements from the group, then A, the binary operation. So A, this circle B. So this, instead of this circle, you imagine any operation such as plus or multiplication. So this the binary operator acting on these elements A and B should also belong to the group G. So this is property is known as closure. Second is uh, the it should have an inverse, and it should have an universal element in it. So wait, and um, there uh, a universal ident an identity E such that uh, you get when this identity element, uh, it also belongs to G, is such that the binary oper when the identity element acts on that uh, element A, it gives back the same element unchanged. So there must exist such an identity element in a group. In third property is that there exists an inverse. There exists an inverse. A dash belongs to G such that when it operates on the uh, element, you get back the identity itself. So this is known as closure. This is known as identity, and this is known as inverse. Okay. So now, uh, now which among these options uh, do you think is uh, it does not satisfy the properties of a group? Can anyone tell, given these properties? So you have these four options, and which one do you think does not satisfy these properties? Anyone? Okay, I missed out one more property, so that is the associative. So this one should actually come before. So this one should be 2. This is 3, and this is 4. Uh, if the if the property is associative. So if A operates on B operates on C, so if first you find out B B operates on C, and then you find the operation of A on that operation. So this is the same as if you did this first. So first you do AB and then you do C. So this is known as associative. Associative. So now, given the four properties, which among these four options, which one do you think? So option A. So there's it's saying natural numbers under addition. So you're right. So because which property do you think that natural numbers violate among these four properties? Uh, Additive identity, right? So it you're right. So it does not have zero. Natural numbers, uh, no zero. So the additive identity is missing. You're right. So no additive identity, and there will also be no inverse because there is no identity in the first place. So no inverse also. So option A is the right answer. So for other options, if you check, so they will all satisfy all the four properties of a group, and a group need not be restricted to this mathematical operation such as plus or minus. It is a broad concept and can be applied to any operation. So but for the purpose of this course, it's mostly applied to mathematical operations. So moving on to the next question. So let A be a group with 50 elements, and then A cannot have a subgroup of cardinality. So for this question, so we'll refer to this Lagrange theorem. Lagrange theorem. It says that if H is a subset of G, G is a group, then H is a subgroup of G, then cardinality of H divides cardinality of G perfectly, which means that this cardinality of H should be multiple, sorry, factor of this cardinality of G. So here A is the 50 elements, it's the bigger group. So this 50 is your cardinality of G, the bigger group. So this subgroup, this is your H. So what cannot have the cardinality? So which of the following are factors of 50? So if you write 50, so you have 1, you have 2, you have 5, you have 10, you have 25, you have 50. I think I'm not missing out anything. So these are the factors of 50. So, so now among these options, option B is 15, which is not a factor of 50, and therefore it cannot be the size of a subgroup of G, of this big group A. So this is the Lagrange theorem. So so all you have to do is just remember this theorem, and it's useful mostly in cryptography and stuff like that. But for this course, only knowing the theorem is enough. Moving on to the next question. So Umesh has six different crayons. He has a graph of a friendship network with six vertices: A, B, C, D, E, F. A is a friend of B, B is a friend of C, C of D, D of E, E of A. As you can see, this expression says that it is a chain. This, this is a friendship chain. So from here we can form the graph. You have A. A is friends with B. B is friends with C. C with friends with D. D with E. And E with F. Now he wants to color the nodes of this graph so that no two adjacent nodes will get the same color. In how many ways can you color the graph? So for A, he has six choices. So six different crayons means six choices. Now for this is a path graph and only this much uh, information about the friendship is stored. Nothing is said whether A is friends with C. So we are assuming that A is not friends with C. So now for six, so coming to the first node, he can pick any of the six choices. So six choices. So then moving on to B, he has five choices. Why? Because he cannot choose the color that was chosen to color this node A. So leaving that color, he has left five choices. Now coming to C. C again, he has total of six choices, but he cannot use the color that was used to color B. So, but he can use the color that was used to color A. So again, it is five choices and not four. So if C was connected to A, then C there would have been four choices. But since C is not connected to A, the choices for coloring node C is 5. And similarly, 5 choices for all the other nodes by the same logic. So this total choices would be 6 into 5 into 5 into 5 into 5 into 5. So you have 5 times 5 and 6. So option B, 6 into 5 to the power 5. I hope this is clear. Let us move on to the next question. So, in how many ways four letters from this set A, N, I, L, I, N can be picked considering all permutations? So, again, what we'll have to do is we'll use generating functions. So, we'll write uh, generating function for A. We can pick A 0 time A in one ways. We can pick one letter A in one way. So it is 1 plus x. Generating function for n. So let me wait. I'll use a different color. For n. For n, you have two n. So it is 1 plus x. So one n can be picked in how many? It's one way because both the n's are identical and the second two n's can be picked in x square by 2 factorial because the two n's would be so when you pick two n's so you'll have to divide by 2 factorial so that uh, the the duplicacy in counting is eliminated. So I'll explain this a little better. Just for now, consider this as the generating function. Next, we have I. So I, it is again there are two. So we have 1x plus x squared by 2 factorial and L. So for L, we have only one L, so it is 1 plus x. Now the resultant generating function is like this. Is so you have 1 plus x, 1 plus x plus square by 2 factorial. Then you have 1 plus x square by 2 factorial. And finally, you have 1 plus x again. So what this means is that we have to pick 4 letters from the set. So we have to find x coefficient of x to the power 4. Now, what does this generating function actually give give us? So this generating function actually give us like this. So what we do is first we pick anything uh, from A. So we have only one A. So either we pick it or don't pick it. Next, we have the choice of picking N. So N we have one. We can pick 0 n in one ways, 1n in one ways, and 2n also in one ways. I'll explain why this 2 factorial is coming in the denominator. Next, we have I same as n because there are two, and finally we have L. So this, so for example, you want what you do is any letter, let's say any combination. So for example, a combination would be like this. So you have ILNA. So let's say ILNA. So this for this first, what we'll do, we'll arrange it in this sequence. So we have, we'll first keep A, then we will have N, N, then we'll have I, and then we'll have L. Now this is the first step, that we pick first from A's generating function, second from N's generating function, third from I's generating function, and fourth from L's generating function. And then second is permute it, permute the selection. So this is the way we pick it up. So any sequence that we want to form, any 4 letter, how many 4 letters can we pick? Uh, how many ways 4 letters can be picked is, we first select from A's generating function, from uh, N's generating from I's generating function, and from L's generating function. So that is one. So if it is like this, if the coefficient is like this, like let's say it is x to the power 0, then x2, x1, and finally x1. This is also x to the power 4, but this means we have selected n n I l. So this is one combination. So when we select this n and we do all permutations of uh, these, so what we get is we'll have to divide by 2 factorial because of this n present. That's why these 2 factorials are coming in the denominator. So basically the coefficient of x to the power 4 will give you all such combination, and that is how you get all uh, the 4-letter word. So this ANIL would also means they have asked us only to find 4 letters, so they have not asked us to form any word. So we don't have to do a permutation over this. So it is only we pick the 4-letter words, and whenever there is duplicacy, we divide it by the number of uh, same occurring elements, that is 2 factorial and 2 factorial. So we'll have to find the coefficient of x to the power 4, and if you find out that, it will turn out to be 102. So of this expression, so that is how you get the 4 letters words. So and okay, so can considering all permutation, so what you do is, if you find all the coefficients of x to the power 4, so you just divide it by 4 factorial. That will give you all the permutations, because uh, this expression will contain all the permutations of A and IL, and that is how you get 102. Okay. Uh, Moving on to question 6. In how many ways you can write 6 as a distinct summand? So for 6, we can write it as 6. We can write it as 5 plus 1. We can write it as 4 plus 2. We can write it as 4 plus 1 plus 1. We can write it as 3 plus 3. We can write as 3 plus 2 plus 1. And write as 3 plus 1 plus 1 plus 1. Can write it as 2 plus 4. 2 plus 3 plus 1. 2 plus 2 plus 1 plus 1. 2 plus 1 plus 1 plus 1 plus 1. Can write as 1 plus 5 plus 1 has already been covered, so we can write as 1 plus 1 plus 1 1 plus 1 plus 1. So I think there are total of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think this won't be there because we have already counted it as 4 plus 2. So now, among these 11 ways in which 6 can be broken down, we have distinct summands, means the digits getting added are distinct. So we have this, as a distinct, where this one is also distinct, this one is also distinct, and which one is 1, 2, 3? This won't be there either. And 1, 2, 3, 4. And anything else? So 6 can be written as distinct summands in 4 ways. So you have option A, 4, which is the right answer for this question. Okay. So what are the elements of Z9, that is integer modulo 9? So this gives you remainder upon division by 9. So for example, you have uh, any number, let's say 71. So when you divide by 9, it is 71 can be written as 63 plus 8 over 9. So that is 7, 8 over 9. So this remainder, this is what is stored in the integer modulo. So it will have zeros. 0 means it is perfectly divisible by 9. Then it will have everything 1, 2 up to 8. But it won't have 9 in it, because 9 divide by 9 would give back 0. So 0 already take care of that. So it would be 0 to 8. So option D is the right answer. So for any general n, it would be 0 to n minus 1. Okay. Moving on to next question. So you are given a complete graph with 15 nodes and 26 letters. So complete graph means every node is connected to all the other nodes in the graph. In how many ways can you denote with a unique letter such that no two adjacent nodes will have the same denotation? So for first node, you have 26 choices. Second node, you have 25 choices, because the second node cannot take the denotation given to the first node, and because it is connected to the first node. For the third node, it will have 24 choices, because it cannot have, it is connected to 1 and 2, both the first and second uh, one. So it cannot have 1 and the choices of 1 and 2. Similarly, the second node cannot have the choice of 1. So like this, the 15th node will have 12 choices, because 26 minus 15 plus 1. So that is how we get 12. So it won't have the choice. So 1, 2 up till 14, uh, it will cannot have the choices taken by these nodes. So the product would be of the chromatic polynomial of this complete graph with 15 nodes would be D, 26 into 25 into 24 into 12, because just multiply the choices. So total choices would be 26 into 25 into 24 up to 12. So that's option D. Coming to question number 9, let G be a group of 40 elements. The largest possible group subgroup G of other than G itself uh, would be. So again, we use Lagrange theorem. So the largest subgroup will be a factor of the size of the big group itself. So the factors of 40 are, you have 1, you have 2, you have 4, you have 5, 8, 10, 20, 40. So these are the factors of 40. So largest possible size of the subgroup. So among these, the other than G itself, so this will be a trivial group. So 1 and 40 we'll have to uh, leave aside. So the largest subgroup can have size 20 because this is the largest factor less than 40. So option B, 20 is the right answer for this question. Coming to question number 10, so we have Z7 with plus. So this is uh, plus modulo 7 actually. So it is not just the ordinary plus. You take plus and then take modulo 7. So it is a group. What is the inverse of x in this group? So by definition, so let's call it x. So by definition, if you add the inverse, operate the inverse on number 3, so it is like this. X would give you the identity is 0 here in addition. So what this binary operation is x plus 3 mod 7 is 0. So which means that x plus 3 is multiple of 7. So now what does Z7 has? Z7 has these elements 0, 1, 2 up to 6. So now X belongs to Z7. So you pick any X from this set and add 3. So which of them would be a multiple of 7? So if I do, if I add 3 to the entire set, what will I get? I'll get 3, 4, 5, 6, 7, 8, 9. Right. So now which among them is, among these 7 numbers is a multiple? So 7 itself. So this is when uh, we add x equal to 4. So when we took x equal to 4 and added 3, we got a multiple of 7. So x is equal to 4. So option D is the right answer for this question. So that brings us to the end of our discussion for this session. So if you have any questions or you want me to discuss any questions, so you can ask now. If not, then we can close the session for today. So if no one has any doubt, and this is the last class, so wish you all the best for your exams. And if you have any doubt, you can always reach out to me on the email address provided in the course website. So thank you for joining in. So We'll have one more tutorial session tomorrow, and after that, all the best for your exams. So, thank you, everyone.